A very good morning to all of you. Welcome to all the dear students for this session of chemistry, P block elements. Among the group 16 elements, we have studied about their common atomic properties, physical properties and chemical properties. Then anomalous behavior of oxygen. Then we have studied about the preparation properties and uses of oxygen, oxides and their classification, then preparation properties and uses of ozone and the importance of ozone layer. Now we will shift our study to the second element, sulfur. Sulfur is the second element in the group 16, which is in the solid form. Sulfur exhibits many allotropic forms, out of which only two are very important. Rhombic sulfur, which is also called as alpha sulfur, and monoclinic sulfur, which is called as beta sulfur. So rhombic sulfur and monoclinic sulfur are the two main allotropic forms of sulfur. Now how do we prepare rhombic sulfur? Rhombic sulfur is prepared by the evaporation of a solution of roll sulfur in carbon disulfide. So we have to dissolve roll sulfur in carbon disulfide, prepare a solution and heat it. When the evaporation of solvent takes place, we get the crystals of rhombic sulfur. So this rhombic sulfur is insoluble in water, slightly soluble in organic solvents like benzene, alcohol, ether, etc. and soluble in carbon disulfide, using which we have gone through the preparation. Then the second form is called beta sulfur, monoclinic sulfur. How do we prepare monoclinic sulfur? First we have to melt the rhombic sulfur in a dish, heat it. After heating, slowly it is kept for cooling. On cooling the hot solution, a crust, a solution in a ಮೇಲ್ಮೈಯಲ್ಲಿ ದಪ್ಪ ಹೆಪ್ಪುಗಟ್ಟುತ್ತದೆ, solution in a solid state. The crystals, that is a crust, rhombic sulfur is melted in a dish, then cooled till the crust is formed. Two holes, ಆ ದಪ್ಪ ಅಲ್ಲಿ ಆದಂತಹ ಹೆಪ್ಪುಗಟ್ಟಿದ ಕ್ರಿಸ್ಟಲ್ಸ್ ಅಲ್ಲಿ ಎರಡು ತೂತುಗಳನ್ನು ಮಾಡಿದರೆ ಆ ಲಿಕ್ವಿಡನ್ನು ಹೊರಗೆ ತೆಗೆದ್ರೆ the crystals, the crust is removed, which contains the needle shaped crystals of beta sulfur or monoclinic sulfur. Now before going to the shape, I want to tell you one more thing. This alpha sulfur and beta sulfur are interconvertible. Are interconvertible. 369 Kelvin is the temperature. So what does it mean? Alpha sulfur is stable below 369 Kelvin. It is stable. But once it reaches 369 Kelvin, it changes into beta sulfur, which is stable above 369 Kelvin. So 369 Kelvin, below this alpha sulfur is stable, above this temperature beta sulfur is stable. You can ask me, what about 369 Kelvin? Both exist in their stable forms. So this temperature at which the two allotropic forms are interconvertible is called as ಟ್ರಾನ್ಸಿಷನ್, ಬದಲಾವಣೆಯ ಟೆಂಪರೇಚರ್. ಒಂದು ರೂಪ ಬಹುರೂಪ ಇನ್ನೊಂದು ಬಹುರೂಪವಾಗಿ ಬದಲಾವಣೆ ಆಗುವ ಟೆಂಪರೇಚರನ್ನು ಟ್ರಾನ್ಸಿಷನ್ ಟೆಂಪರೇಚರ್ ಅಂತ ಕರಿತೇವೆ. ನೆಕ್ಸ್ಟ್ ಅಬೌಟ್ ದಿಸ್ ಎಲಿಮೆಂಟ್ sulfur, they are octa atomic. ನಾರ್ಮಲಿ 8 atoms, 8 ಆಟಮ್ಗಳು ಒಟ್ಟು ಸೇರಿ ಒಂದು ಅಣುವನ್ನು, ಮಾಲಿಕ್ಯೂಲನ್ನು ಮಾಡ್ತವೆ, octa atomic. And both the forms have puckered, ಅಂದರೆ ನೇರವಾದ ಯಾವುದೇ ರಚನೆ ಅಲ್ಲ, ನೇರಿಗೆ ಒಳಗೆ ಈ ಥರ ಬಂದ ಒಂದು ಕ್ರೌನ್ ಶೇಪಿನಲ್ಲಿ S8 ಮಾಲಿಕ್ಯೂಲ್ಗಳ ಶೇಪ್ ಇರುತ್ತೆ. ಬೋತ್ ಆಲ್ಫಾ ಆ್ಯಂಡ್ ಬೀಟಾ ಸಲ್ಫರ್ಸ್ ಎಕ್ಸಿಸ್ಟ್ ಇನ್ ದಿಸ್ ಫಾರ್ಮ್ ನಾರ್ಮಲಿ. And in the recent decades, even these, instead of 8, sulfur 6 to sulfur 20, with 6 or up to 20 sulfur atoms are found in the cyclic form. So one of them is S6 form identified or synthesized is in this chair form. We call this as a configuration or conformation as a chair form. So this is the chair form. And one more thing very important here is S2 species is present at high temperatures of nearly 1000 Kelvin, at which this S2 form of sulfur is paramagnetic like O2. Oxygen is paramagnetic, you know very well, and at 1000 Kelvin this S2 species found at this high temperature is also found to be paramagnetic like oxygen. So these are some of the informations about the allotropes of sulfur. Two types, rhombic and monoclinic, or they are also referred to as alpha and beta, and their shapes. Next we will move on to another concept here, preparation, properties and uses of sulfur dioxide. Sulfur dioxide is an important component of sulfur dioxide. So first we will see some of the preparation methods. First one, by burning sulfur in oxygen. When sulfur is made to react with oxygen, it gives sulfur dioxide. But in this method, along with sulfur dioxide, traces of sulfur trioxide are also formed. So by burning, or you can call it as oxygen, oxidation of sulfur into sulfur dioxide. Next is action of dilute HCl, dilute acids on sulfite salts. So sulfites contain common ion SO3 to plus. When H plus acid, any acid is added, all are in the aqueous medium, it gives sulfur dioxide and water is produced. Sulfur dioxide is produced and water. The third one, by the oxidation of the sulfide ores. That is, for example, FeS2 iron pyrides, when reacts with oxygen, it gives iron oxide along with the formation of sulfur dioxide. So sulfur dioxide is formed in these methods. This is oxidation of sulfide ores, or we call this as roasting, heating in the excess of oxygen, any sulfide ore. So next, coming to the physical properties. It is a colorless gas with the pungent, suffocating odor. It is highly soluble in water, liquefies at room temperature at around 2 atmosphere pressure. And then coming to the chemical properties, it is an acidic oxide. So acidic nature we will see. When sulfur dioxide is passed through water, we get an acid called sulfurous acid. So sulfurous acid is formed when sulfur dioxide is passed through water. So sulfur dioxide, when passed through sodium hydroxide, we get sodium sulfite salt and water is formed. So this shows this is acid with base gives salt and water. But in this reaction it behaves like carbon dioxide, and if you pass more sulfur dioxide into this solution, it gives sodium hydrogen sulfide. So the behavior of sulfur dioxide is very similar to that of carbon dioxide. So first it gives sodium sulfite, and if you pass excess of sulfur dioxide to sodium sulfide solution formed, you will get sodium hydrogen sulfite. So next we will discuss about another reaction with the chlorine. So sulfur dioxide when mixed with the chlorine in the presence of activated charcoal gives a compound SO2Cl2 called as sulfuryl chloride. This question has appeared in one of the annual question papers. So SO2 plus Cl2, the students had to write the product SO2 Cl2, sulfuryl chloride. So sulfur dioxide reacts with chlorine to give sulfuryl chloride. Then oxidation, that is reaction with the oxygen. It is catalytically oxidized sulfur dioxide, oxygen in the presence of vanadium pentoxide catalyst, it gives sulfur trioxide. So the reaction of sulfur dioxide with the oxygen at elevated temperatures in the presence of vanadium pentoxide catalyst will give you sulfur trioxide. The next property is reducing property. Sulfur dioxide acts as a reducing agent because it easily gets oxidized to sulfur trioxide. The one which gets oxidized is a reducing agent, or it also produces nascent hydrogen when it is put into water. That is, it gives sulfuric acid along with the release of 2 nascent hydrogen available for reduction. So for this purpose, sulfur dioxide solution is a very good reducing agent. So we will see 2 examples. It reduces ferric ions, that is Fe3 plus, ferric ions Fe3 plus into ferrous ions or Fe2 plus, Fe2 plus ions. So SO2 2Fe3 plus 2H2O will give you sulfur dioxide is oxidized itself to sulfate, and ferric gets reduced to ferrous, and of course 4H plus is formed. Okay. So sulfur dioxide reduces ferric ions into ferrous ions and itself gets oxidized to sulfate ions. So it reduces permanganates ion, that is MnO4 minus into Mn2 plus manganese ion. Example 5SO2 2MnO4 minus plus 2H2O gives 5SO4 2 minus plus 2Mn2 plus 4H plus. So sulfur dioxide reduces manganate ion to manganese, because here the oxidation number +7, it becomes +2. So decrease in the oxidation number is reduction. So this reduces to Mn2 plus. And this can be used as a test for sulfur dioxide gas. Why? Because there is a visible change, because this all the permanganates are pink in color. So when the colorless sulfur dioxide gas is passed through pink solution of permanganates, we get, this is colorless, a colorless solution. So the pink color of potassium or any permanganate solution is decolorized when the colorless gas sulfur dioxide is passed through it. Therefore, this can be used as a test to identify sulfur dioxide gas. Now, about the structure of sulfur dioxide, it is very similar to the structure of ozone. Because sulfur is in the same group, it is a coordinate bond. Here it is a simple multiple covalent bond. This is one canonical form which is in equilibrium with another canonical form where the positions of these double bonds are different. This is a coordinate bond and both the electrons are donated by sulfur. So these two are canonical forms. The actual structure is the resonance hybrid of these two structures where both these bond lengths are same. So the bond lengths are same due to the delocalization of these pi electrons. Now coming to the uses of sulfur dioxide. Sulfur dioxide is used in bleaching of sugar and petroleum industries. It is used as an anti-clor, germicide. It is used to bleach wool and silk. It is used in the preparation of sulfuric acid, which is a very important compound in industries. It is used in the preparation of sulfides, calcium hydrogen sulfide, etc. Liquid sulfur dioxide is used as a solvent in some of the reactions. So these are the uses of sulfur dioxide. So we have completed the preparation, properties and the structure uses of sulfur dioxide. Next we are moving to a compound which is called king of chemicals. That is a very important compound which is directly or indirectly used in almost all the industries in one or the other form. So this is called king of chemicals, and the growth of the industries in a nation was normally decided by the amount of sulfuric acid prepared. So that much importance is given to sulfuric acid, because more the consumption of sulfuric acid means more are the industries. So sulfuric acid is a very important oxo acid of sulfur. The sulfuric acid is prepared by a process called contact process by using sulfur in the large scale. So in the large scale it's prepared by a method called contact process. Then coming to the properties, it is a, you have already seen sulfuric acid in the laboratory. It is a colorless liquid, but it is more viscous than hydrochloric acid and nitric acid due to hydrogen bonding. It is viscosity ಸ್ವಲ್ಪ ದಪ್ಪ ಅಂತ ಹೇಳ್ತೇವೆ, oily or viscous liquid ಅಂತ ಹೇಳ್ತೇವೆ. And very important thing you have to remember is its action with water. So dealing with concentrated sulfuric acid, we have to be very, very careful in the laboratory, because when we dilute or when water is added to sulfuric acid or sulfuric acid to water, a lot of heat is given out. So if you take sulfuric acid and then add water for dilution purpose, there are more chances that the acid will splash outside causing damage, and therefore normally dilution ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡನ್ನು ನೀರು ಹಾಕಿ ಡೈಲ್ಯೂಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಅದನ್ನು ಹಾಕುವಾಗ ನೀರನ್ನು ತಗೊಂಡು ಅದಕ್ಕೆ ಆ್ಯಸಿಡನ್ನು ಕಾನ್ಸ್ಟೆಂಟ್ ಸ್ಟರಿಂಗ್ ಮಿಕ್ಸ್ ಮಾಡ್ತಾ ಹಾಕಬೇಕು. ಸೊ ಆ್ಯಸಿಡ್ ಬೀಯಿಂಗ್ ಡೆನ್ಸರ್, ಅದು ಹಾಕಿದ ತಕ್ಷಣ ಕೆಳಗೆ ಹೋಗುತ್ತೆ, ಆ ಹೀಟ್ ನೀರಿನಲ್ಲಿ ಹರಡಿ ಹೋಗೋದ್ರಿಂದ ದ ಡೇಂಜರ್ ಈಸ್ ಲೆಸ್. ಅದರ್ವೈಸ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡಿಗೆ ನೀರು ಹಾಕಿದರೆ ಅದು ಮೇಲ್ಮೈಯಲ್ಲಿ ಪ್ರೊಡಕ್ಷನ್ ಮಾಡಿದ ಹೀಟ್ನಿಂದಾಗಿ ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡ್ ಸಡನ್ ಆಗಿ ಹೊರಗೆ ಹಾರುವ ಚಾನ್ಸಸ್ ಇದೆ. ಹಾಗಾಗಿ ಡೈಲ್ಯೂಷನ್ ಆಫ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡ್ ಈಸ್ ಡನ್ ವಿತ್ ವೆರಿ ಮಚ್ ಕೇರ್ ಇನ್ ದ ಲ್ಯಾಬೊರೇಟರೀಸ್. ದೆನ್ ಕಮಿಂಗ್ ಟು ದ ಕೆಮಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡ್, I will discuss these properties by making 4 categories. One, as an acid, acidic nature. Next, high volatile, used in the preparation of highly volatile substances. Because of this low volatile nature or low volatility, that means high boiling point. Fourth one is strong affinity for water. I told you about this. And 4 is as an oxidizing agent. So I will discuss about these one by one. First, let us see acidic nature of sulfuric acid. Sulfuric acid, in the name itself there is acid, it is an acid, and it dissociates, all the acids should dissociate to give H plus ions, and it dissociates to give H plus and hydrogen sulfate ions, and the dissociation constant Ka1 is more than 10. So more the dissociation constant, more will be the ionization, and this HSO4 minus then dissociates to give H plus and sulfate ions, and Ka2, you know polybasic acid dissociate in more than one step, and KO2 is approximately 1.2 into 10 to the power minus 2, which is very, very low. So Ka1 is very high, which means the sulfuric acid mostly in this dissociated form, and this dissociation extent is very, very less. Therefore, the dissociation of sulfuric acid or sulfuric acid is mostly present in this form in the solution, or to more extent it is formed. What are the salts of sulfuric acid? When one hydrogen is replaced by a metal, for example sodium hydrogen sulfate, such salts are called acid salts. It is salt as well as acidic because of the presence of one more hydrogen which can be replaced. This is acid salt, hydrogen sulfates. If both the hydrogen atoms are replaced, it is sodium sulfate with no hydrogen. They are called normal sulfates. So I can also replace this by acid sulfates. So these two are the salts prepared by sulfuric acid when it is made to react with the bases like sodium hydroxide or potassium hydroxide, calcium hydroxide, any base. Then we will discuss about the properties of sulfuric acid, one more property, where the properties low volatility or high boiling point of sulfuric acid is made use in the preparation of more volatile acids, which boil, have low temperature, boiling point, early boiling, more volatile acid. For example, if you have a metal salt of this form which is made to react with the sulfuric acid, it gives HX, an acid, and a salt sulfate, where X can be fluorine, chlorine, or even nitrate. So what does it mean? This is a salt, for example sodium chloride. Sodium chloride having M as sodium and X is chlorine, plus sulfuric acid. Sulfuric acid, high boiling point, it is less volatile, does not get vaporized easily, which is used in the preparation of HX. So it is 2HCl plus Na2SO4. So what has happened here is, I have used a less volatile sulfuric acid concentrated to produce a more volatile acid, hydrochloric acid. So in this way I can prepare nitric acid also. If I replace Cl by nitrate, NO3, NaNO3, you will get nitric acid. So we make use of less volatile nature of concentrated sulfuric acid here. The next property is drying or dehydrating agent. So as I have already told you, concentrated sulfuric acid lot of affinity towards water to form hydrates when lot of energy or heat is given out, and therefore concentrated sulfuric acid can be used as a drying agent as well as dehydrating agent. It can be used to dry wet gases prepared in the laboratory. Moist gases can be dried. The sulfuric acid is able to remove the water present along with the moist gas only if the gas doesn't react with sulfuric acid. Suppose the gas to be dried reacts with sulfuric acid, this is not possible. So you cannot use sulfuric acid in such a case. It can be used as a drying agent only in such cases where the gases do not, or the compounds do not react with the concentrated sulfuric acid. Sulfuric acid is not only a drying agent, it also is able to remove the elements of water chemically combined in the substances, especially in organic compounds like I can take, this is sucrose, C12H22O11. This is an organic compound. If I take sugar crystals in a test tube and add concentrated sulfuric acid, immediately the charring smell, ಕರಟಿದ ವಾಸನೆ ನಮ್ಮ ಮೂಗಿಗೆ ಬರುತ್ತದೆ. ಚಾರಿಂಗ್ ಅಂದರೆ ಸುಟ್ಟ ವಾಸನೆ ಬರುತ್ತದೆ. ಆಗ ಅಲ್ಲಿ ಆಗೋದು ಏನು ಅಂದರೆ 2:1 ರೇಷಿಯೋ ಆಫ್ hydrogen and oxygen is present. This is 11H2O is totally removed by the concentrated sulfuric acid because it likes water so much. It removes hydrogen and oxygen which is present in 2:1 ratio to give carbon and 11H2O. So this is called as sugar charcoal. So this is charring action of concentrated sulfuric acid on this. So when you deal with sulfuric acid, you have to be very careful in the laboratory, because if it falls on your skin, it removes all the water molecules and the skin gets charred. Sutta gayagalagtave. So you have to be very careful. So these are some of the reactions, and there is one more reaction left, is oxidizing nature. Sulfuric acid is moderately good oxidizing agent. It oxidizes many metals, non-metals into sulfates, etc. So, it gets reduced to sulfur dioxide and it oxidizes to the metals and the non-metals. For example, I can take carbon and add sulfuric acid. It gets oxidized to carbon dioxide, where itself gets reduced to sulfur dioxide and with the formation of water. So carbon gets oxidized to carbon dioxide. Sulfur, when added with concentrated sulfur, all these reactions are under concentrated state, concentrated sulfuric acid, it forms sulfur dioxide. So sulfur is oxidized to sulfur dioxide. So you can add concentrated sulfuric acid to copper and heat. Then copper gets oxidized to its sulfate, copper sulfate, with the formation of sulfur dioxide and water. So these are some of the oxidizing actions of sulfuric acid. It oxidizes non-metals as well as some of the metals. So these are the reactions of sulfuric acid. Now what are the uses of sulfuric acid? The limitless uses of sulfuric acid are limitless. It is used as an acid in the preparation of sulfates, hydrogen sulfates, etc. It is used in textile industries. It is used in metallurgy for pickling of metals, cleaning the metal surfaces, electroplating, galvanizing, all these processes in metallurgy. Concentrated sulfuric acid is used. It is used in the preparation of many compounds as drying or dehydrating agent. It is used in paint industry, pigment industries, dyes industries. It is also used as used in storage batteries. So sulfuric acid in one or the other form, it is used in the preparation of many compounds. Even in a nitration process, along with the concentrated nitric acid, concentrated sulfuric acid is used in the preparation of nitro compounds like TNT, TNG, etc. So that's all about the uses of sulfuric acid. So we have studied now sulfuric acid, its physical and chemical properties and uses. Now the last portion in group 16 elements is oxo acids of sulfur. There are many acids of oxo acids of sulfur, about which I will discuss only 4 of them regarding only their structures. So H2SO3 is called sulfurous acid. H2SO4 is called sulfuric acid. H2S2O7 is called pyrosulfuric acid, and H2S2O8 is called peroxodisulfuric acid. So we will see the structure of sulfurous acid, one of which may be asked for 1 mark in the examination. All these are tetrahedral in nature. Sulfur with the 2 lone pairs and 2 single electrons is able to form 4 bonds, 2 multiple bonds and 2 single covalent bonds. So with the 2 hydrogen atoms it forms 2 OH group with basicity 2 and a lone pair of electron. 1 lone pair is used to bond with oxygen and 2 single electrons with the oxygen forming covalent bonds and 1 lone pair. So this is the structure of sulfurous acid. Now there is 3 and there are 4 electrons, one more oxygen, and this electron forms a multiple bond with oxygen. In sulfuric acid you can have connection like this in building up the structure. So this is sulfurous acid. So this lone pair of sulfur bonds with oxygen with a multiple bond. This is sulfuric acid. Now how do you get pyrosulfuric acid? Pyro means heating. So when sulfuric acid is heated, a water molecule is removed and you get pyrosulfuric acid. We will see this. If you write OH this side, I can write this as oxygen this side and write OH. You write 1 more here with a double bond and 2 OH bonds like this, or you can write it like this also, slightly up also you can write. Okay. Now remove 1 water molecule, H2O you remove. So the bond comes like this. So H2S2O7, 3 plus 3. So H2S2O7. This is pyrosulfuric acid formed by, you have to write 2 sulfuric acids and remove 1 water molecule by the nearby 2 OH bonds. Now peroxo means 1 extra oxygen, like water H2O and H2O2. Peroxo means 1 oxygen is more, peroxide bond. So you add 1 more oxygen in between and that will give you this compound. So this is double bond, here is 1 OH, here there is a double bond, there is 1 OH and already there is 1 O. You add a peroxide linkage, 2 oxygen bonds there, it's called 2 oxygens together is called peroxide bond, and that is the structure of peroxodisulfuric acid. So these are the structures of 4 acids given in your syllabus, about which you may be asked 1 mark question. So now this completes the study of sulfur and its compounds. We have studied about the allotropes of sulfur, preparation properties and uses of sulfur dioxide, and then we have studied about the properties, physical and chemical properties and uses of sulfuric acid. Then we have seen how to write the structures of these 4 oxo acids of sulfur. This is the end of group 16 elements. Thank you for watching the video, students. We will continue with the group 17 in the next session. Thank you one and all.